Hello everyone, I'm Blue. Today I'm going to talk something about the black hole. First, may I introduce what is black hole? Let's imagine this is the space and time. According to Einstein's general relativity, mass can twist the space and time and then drag anything towards it, like the water. And this is called the gravity. And let's imagine if the mass gets bigger and bigger and finally a hole appeared on the time and space, and anything dragged towards it finally disappears from the time and space, and this hole is called the black hole. Of course, this is not the strict definition of the black hole. This is just an interesting metaphor. Next, scientifically, I'm going to talk something about the properties of black hole. First, let's start with the originality. When the fuse for nuclear diffusion runs out, not diffusion, I'm sorry. When the fuse for nuclear fusion runs out, the star prepares to die. Its core rapidly contracts, collapses, and explodes under its own gravity. With its size getting smaller and smaller, its density gets bigger and bigger. Finally, even the neurons are crushed by the extremely big gravity, and anything close it gets sucked in. At this stage, the black hole forms. The existence of black hole was first predicted by the Einstein's general relativity equations shown on the left side of this page. You can have a look here. Next, we're going to talk something about the properties of the black hole. First is the singularity and the Schwarzschild radius. This is the formula of the Schwarzschild radius, and here is the singularity and the event horizon. Singularity is a point with zero size and infinite density at the center of the black hole. And event horizon is the sphere bounded by the Schwarzschild and the singularity. Anything happened in the event horizon cannot be known by the people outside the event horizon because the light never comes out. Then we're going to talk something about the no-here theorem. This theorem was proposed by Stephen Hawking. It says that any properties of the black hole can be described by three terms, that is mass, angular momentum, and electrical charge. This is really surprising, right? Because for us, black hole is something that is very mysterious, but Stephen Hawking said, actually, it is very simple. It can be described by merely three terms that is shown here. The third property is about Hawking radiation. First, let's imagine that it is a particle, a virtual particle in the vacuum. Near the black hole, the gravity is so big that the virtual particles of the vacuum was teared apart into two particles. This is the particle and this is the antiparticle. With one falls into the black hole, the other escaped. So when we conclude that the black hole actually radiates. Then is an image we have taken of the black hole. This image was taken 2 years ago but published in less than 2 weeks ago. This is the black hole from the AMA1D07 galaxy, which is 55 million light years from the Earth. We can see from the picture that the size of the black hole is very surprising, about several times bigger than the solar system, right? So the image of the black hole strongly supported the general relativity. Again, we have proved that Einstein was right. I may say that Einstein was really a great person, and the general relativity is of great power. However, no theory was perfect, and no theory was 100% right. We must modify our theories with observations and experiments. Despite the process was tough and difficult, we human will never stop exploration. Okay? Thank you for watching this video. That's it.